Hi there. So in this video, we're going to be practicing or learning, a little bit more about costs. In the first lecture on costs, we went through short run costs like marginal cost and then three average costs. In this one, we're going to learn about actually what do costs kind of look like in the long run when all of your variables or all of your inputs are actually variable, where you can change, for example, the number of machines that you have and the number of workers that you have. I really like Jacob Clifford's video on the long run average total cost curve. If you Google search ACDC economics LRATC, this will come up, and he explains it really nicely. I'm also going to go ahead and deliver this lecture to explain some of the more specific elements that you need to know to be successful for micro. So let's get started. Now, we've already learned about short run ATC curves in the last lecture. That's the average cost per unit. And the existence of these short run average total cost curves is because you have like this number of workers, and if you vary the number of workers, you get kind of a downward slope and then an upward slope in terms of the average cost. And the existence of that downward and then upward, the upward part is because of diminishing marginal returns. So that's because there's some fixed inputs. Each ATC, therefore, in this picture kind of represents some different combination of fixed inputs and variable resources that go along with it. So it's helpful to think about like a plant, the physical plant, not a growing plant, the capacity of the plant. So you might have option one is have like one factory and 10 workers. And option two might be two factories and 20 workers. Option three might be three factories and 30 workers or so forth, right? Four factories and 4 workers. And it represents kind of different possibilities of where your short run firm might be actually in terms of the inputs that you're actually using. And as a company, you would look at this and you'd go, well, if we have this big of a company, then my average cost at Q1 would be right here. Is kind of, that's at Q, that's SRATT's 2. My average cost would be right here for SRATC 1. So Q1, the lower cost, right, would be if I produced at SRATC 1. If I were at 2 factories, though, and I had 20 workers, my average cost would actually be much higher of producing quantity 1 than if I only had 1 factory. And you think about for a second why that would be. Like SRATC2 is a bigger factory and more workers. Why would there be higher average cost for this very low quantity of output? Well, it's just because you're underusing all of your resources. You have some excess capacity is what we would call it. Contrast that to Q2, and you could see like, well, if we're SRATC1, the actual costs of producing Q2 is pretty high, but if we have a larger quantity, it might make more sense for us to be in that doubled the factory size and produce using SRATC2. So in other words, if I'm a company and I'm thinking that I'm pretty much always going to be producing Q1, I would prefer to be at SRATC1 because it gives me a lower cost than SRATC2. But if I knew that maybe demand was a lot bigger and it was a permanent increase and I was going to be producing Q2 for an extended period of time, I would probably want to switch and actually build a new factory because then I would get lower average costs over time. So option 3, right, option 4, that kind of thing. We're going to circle the optimal options for each of these various quantities. And so here we could see option 1 would be SRATC1, option 2 is SRATC2, and so forth. If we're producing Q1, we're only given 2 choices, SRATC1 or SRATC2. Well, at Q1, the SRATC2 is higher than the SRATC1, so we would produce using SRATC1. We would be in the short run average total cost curve 1. That would be like 1 factory, 10 workers. But if we knew that we were permanently increasing to Q2, maybe there's a big increase in demand, I might want to switch to SRATC2 because, again, it's a lower average cost. So I'm going to switch here and circle 2. Now at Q3, we take a look at it and we go, well, this lower cost is coming from SRATC3, and this higher cost is coming from SRATC2. So you could either produce using SRATC2 and have really high cost, or SRATC3 and have lower cost. Well, I would prefer the lower cost. If I'm at quantity 4, well, here, I don't even have any other curves. I guess even if I extended these all the way up here, maybe those would be like really high values for SRATC4 and SRATC2. But at quantity 4, it just makes a whole lot of sense to just use the third option, which is SRATC3. Now, if we were Q5, like if we had another row down here, if we had one more row, well, then pretty clearly SRATC4 would be the best option because it's lower average cost than SRATC3. So that just kind of allows us to understand what's going on in this graph up at the top. This question here says option 3 at Q4 So option 3 at Q4 minimizes the ATC. Does that maximize profit? No, because max profit is at MR equals MC. So this may not necessarily correspond to where we need to end up, right? If the demand for our product leads to a marginal revenue that causes us to have MR equals MC at quantity 1, then we should absolutely just stick with SRATC 1. So it really depends on the quantity where MR equals MC is actually how much we should produce. The size of our company, we could keep getting bigger and bigger and bigger ad infinitum, but if there's not very much demand for our product, well, then that would just be silly, right? We could push those average costs really low, but if there's nobody there to buy it, then why would we do that? Now, we're going to construct using this set of curves. We're actually going to construct what's called a long run average total cost curve, which really represents kind of all these possibilities. I'm going to zoom out a little bit so you can see it better. So if we talk about all these possibilities, these LRATC is what it's going to show is the lowest average total cost at every single output level. And it kind of allows us to compare like, okay, if our output level is at any of these output levels, where should we be in terms of an SRATC? So what I'm going to do is mark the portion of each SRATC that minimizes ATC. So in other words, it's going to be like right here and right here and right here, and then another one right here. And then I'm going to kind of connect those and go like that. And we can see it kind of coming back up again as well. So we're kind of sketching out this like long, nice flowing graph. That's actually the long run average total cost curve. It's the kind of minimum points of all of these possibilities. And it's useful maybe to imagine that within these SRATC3, SRATC4, and so forth, that it's not just 4 SRATCs. You could have one factory or 1.5 factories. You could have like a few extra machines. You think about a factory is a big thing. So you could have like SRATC 1.1, SRATC 1.2, some kind of between SRATCs. Obviously at a very minimal level, like of like one machine, you get a new SRATC, another machine, another SRATC. So it's kind of useful. Sometimes you'll see pictures drawn of this. It'll look like that. It'll give you like a zillion of them, because really there's a kind of an infinite number of these possible SRATCs. And what the LRATC seeks to do is kind of just show what that looks like without having all those little SRATCs on there, the short run ones. So rather than draw all those little U shapes, we're just going to do one of these. Quantity, costs, and we're going to come down, hit our lowest point, and then go flat, and then come back up again. And the reason we're going flat is that that's going to show a range of production. We kind of can divide this into ranges. The range where the LRATC is going down, well, you're increasing the quantity, so we're scaling up the size of the operation, but the ATC, the long run ATC, is decreasing. So we call that the economies of scale range. And right below this is written an explanation of what that means. It's caused by specialization. That's why you get that lowering average cost. And it's caused also by efficient use of equipment, bulk buying, blah, 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 blah. But what it really means is like you maybe increased your firm by 10% and you got 10% more costs as a result, but you got 15% more output. So you got more output than what your costs went up, which means, right, if you think about ATC is equal to the change in total cost divided by the total product. And so, oops, it's not the change, brain fart. It's just the change, or it's just the cost over the product. So we'd say like if your costs went up 10% plus 10%, and your output went up 15%, well, then the ATC is going to get smaller as a result, right? The average is going to fall because your costs only went up 10, but your product went up 15. So it's causing LRATC to get lower. The middle range is constant returns to scale, constant returns to scale. And again, the reason we call that scale is because we're like scaling up the operation. And as we scale up the operation, if we increase the firm again by 10%, in this one, ATC would be positive 10% costs divided by positive 10% product. The ATC would end up staying the same, right? The value that it spits out would be the same. And so it wouldn't change on this vertical axis. The last one is called the diseconomies of scale. range. And this is where you're scaling up the operation, but you're actually causing higher and higher average costs as you continue. And that's because, again, maybe you have 10% bigger firm, so there's 10% more costs, right? So ATC here would be plus 10% total cost, but maybe you only got 5% more total product, in which case it's going to cause that average to go up. It's going to move the average up as opposed to where it used to be, and that's going to be the diseconomies of scale. It would never make sense for a firm to operate within that diseconomies of scale range because they're getting higher and higher costs as a result. So hopefully this helps you. Again, if you need a little bit of extra, actually, that Jacob Clifford video is really good. It's also linked in my playlist. I'll see you next time.